why do we need standby redo logs? When we open our standby database, it's open with reset logs anyway, which creates brand new redo logs. So there seems to be little or no need to have them there. And it's a bit of a misnomer. So let's take a trip down memory lane. When we first started using DataGuard, in fact, even before DataGuard came along, people were doing their own, what I call homegrown standbys, way back as far as Oracle 6 and 7, which was you would manually copy the archive logs over to somewhere and do a recovery of a database. And that was how you keep a DR site active. So this is what we used to do. We would have a primary and we would have a standby, and the primary would have redo logs that would slowly fill. So they would slowly fill up. And once they were full, they would be archived. And then we would copy those full archives over to the standby. Even the early iterations of DataGuard did this. Now, before you take me to task on my diagram, I know we have redo and we have archive redo and they're separate things, but I'm keeping the diagram simple here because it's PowerPoint. It's hard to do. So I'm assuming here our redo is filled, they become archived redo on the primary. And what we used to do is then those full archives would be then sent over to the standby. The problem was, if you had a half full redo log, therefore your current redo log, and you had a catastrophe, that's how much data you lost. And as a result, people started coming up with interesting ways of working around this. They would have very, very small redo logs. Then that would get them into checkpoint problems. Or they would do things like set archive lag targets such that the most they would lose is 600 seconds, because every 600 seconds, even if a redo wasn't full, it would switch to a new one and archive it off. All those really were sort of just damage limitation exercises. We fixed that with the concept of standby redo logs. They are not, as the name suggests, redo logs that will become active when your standby becomes active. They're not for that purpose. Standby redo logs are actually for keeping that data loss to zero, because we want to apply our redo in near real time. What happens is, for each redo log, you have a standby redo log, and as changes occur in your primary redo, they are literally sent over to an equivalent or partnering redo log over on the standby. That's why they need to be the exact same size. They are effectively a symbiotic relationship between the primary redo and the standby. As redo occurs, the RFS process is sending that over to the standby. I say the term partners, and a lot of people have this misconception that that's why if you have 5 redos, you're meant to have 5, in fact 6 standby redos, because people think they're all lined up one-to-one. That's not actually the case. We don't do that. The standby redos are there simply as a accept redo and apply it to my standby. Because that's really all your standby is typically doing, often if it's not in active DataGuard mode, then that can be very, very efficient. So redo number 1 will be sending over to standby redo number 1. When redo number 1 fills up and standby redo number 2 starts working, if standby redo number 1 is not currently being used to apply redo, it'll be used as well. So even primary redo 3, if standby redo number 1 is not actively being used for recovery, it will simply all go to there. So it's one of those weird things. If you go look at some of the database stats, the VDOLA views, it sort of says that the only redo log ever being used is standby redo number 1. That's because your system there isn't that busy. The reason you have to, or we recommend that you have more, as at least one more than redos, is if your machine is really being belted, RFS may be wanting to send information from all your redos on your primary, that's worst case scenario, and therefore it needs a standby redo in which to actually funnel those changes into. But typically, on most systems, if they're running just moderately busy, you'll only see standby redo number 1 in active use. This is how we add them. It's really just a normal alter database command, but you add the standby clause to make sure you actually have standby redos as well. They are a brand new redo log group. So some of the common gotchas, the common mistakes that people make is one, they don't have them at all, because we don't fail or anything. All we do is we simply say this. We'll simply say this: you have no entries in your VDOLA standby log. DataGuard won't fail. It simply goes back to the old behavior. When a redo fills up, then we'll apply the archived redo, thus opening you up for data loss. Another common gotcha is if people are running rack systems, they'll add standby redos and they'll nominate a thread number. And one of the cool things, as I said, because we don't have to have that exact matching between redos and standby redos, we simply use them as demand requires, you can create your standby redos with thread 0, which means any of the redo threads on your primary rack system can take advantage of it. But if you do nominate a thread, then only primary redo from that thread will be able to use it. And so sometimes you end up with these kind of things where in your alert log it says, I was trying to do some work with redo thread 2 from another instance, and I couldn't find a thread 2 equivalent in standby redo. And that's when things get really messy because some redo threads do have them, some don't, and you can get into all sorts of mess. Oh, the last final gotcha, I should say, is your control file has a cap on how many log files you're allowed to have. And once you get into the concept of adding lots of standby redo log files, then you may need to recreate your control file to actually accommodate that many standby redo logs. I think we default to 16. Yeah, so standby redo logs, mitigation against data loss, and it really makes just a really super duper piece of technology now because you get these incredibly low potential of data loss, and with some of the graceful failover stuff, it almost doubles as a really cool clustering solution.